Hello students, welcome to Biswas tutorial. Today we are going to start a topic about common salt. We know that in our everyday life we eat salt so as to maintain the sodium balance in our body and also to make our food tastier. Previously in the previous videos we have learned about what are salts, how are they prepared by the help of your neutralization reaction. We have also learned about how salts can be classified into acidic, basic or neutral salts. If you have gone through the video and if you liked it, please like and subscribe and share among your friends. Today we are going to discuss about common salt. The salt that we eat at home is actually having a formula NaCl, which is sodium chloride. Now, as we know previously, hydrolysis of a salt can let us know about the acid and base from which a particular salt can be obtained. So, if we hydrolyze NaCl, okay, we obtain a particular salt which is HCl and NaOH. We know HCl is a strong acid and it is also a strong acid, and NaOH is also a strong base. Hence the salt NaCl is neutral in nature, is a neutral salt. Okay, it is a neutral salt. Now in a laboratory we can prepare NaCl by the reaction of HCl on NaOH, resulting into the formation of NaCl and H2O. Okay, so in laboratory we prepare NaCl by the reaction of HCl NaOH giving NaCl. But do we require to manufacture NaCl? No, because NaCl or the common salt that we eat is obtained from the seawater and also obtained from the rock that is present in the earth crust. Hope you remember about a particular movement done by Mahatma Gandhi, the Dandi March, where he walked to the Dandi beach, okay, and he collected the salt which were washed away by the sea water, Arabian Sea, okay. He did not pay any tax to the British government. That was the movement that was done. But the science is that we evaporate seawater to obtain salt. So seawater is evaporated and then purified to obtain NaCl. This is one thing, and more one, rocks containing NaCl are mined from the earth's crust. Okay, so NaCl is present in our nature in the seawater, dissolved in seawater, so only seawater tastes salty. Okay, and it is also present in the rocks, that is present in the earth's crust. So when we allow seawater in shallow land and let it evaporate in the presence of sunlight, we obtain salt, NaCl, but the salt is a little brown in color, which needs to be purified so as to remove the other dissolved salts and obtain NaCl from there. Moreover, there are certain rocks that contain sodium chloride. Okay, those rocks are mined from the earth's crust to obtain NaCl. So this laboratory preparation is not done. But if we notice, we will see that the acid and the base which forms the salt are very important. NaOH is used for making soap, detergents. It is used for making bleach. You know about artificial fiber like rayon. Okay, it is also used for paper manufacturing. Moreover, it is also used for purifying bauxite to extract aluminium. Okay, so these are the important uses of NaOH, the base which is required to make NaCl. Okay, and HCl over here is also important for your making PVC plastic utensils. Okay, they are used for purifying metals. These are used as your it is used to clean metals before galvanizing, and there are much more uses of hydrochloric acid. If you go through your book, you will find that hydrochloric acid is one of them. It is also used for making medicines. Okay, it is used for making medicines, cosmetics, okay, and many more. So, as NaCl, the salt that we eat, is present in the earth's crust, in sea water and in rocks. Okay, we can obtain NaCl by some processes which is evaporation and mining. Okay, now we know that the acid and the base which forms the NaCl is very useful in nature. So can we extract the NaOH and HCl from the particular salt that is present in the nature? Yes, we can do so. How do we make NaOH and HCl from the NaCl? This is one of the most important topic that we are going to discuss today, which is the electrolysis of NaCl, which leads to the result in the formation of NaOH along with the formation of two gases, hydrogen and chlorine gas, which may react together to form HCl. We are going to see the electrolysis of NaCl. Okay, we can see the setup over here. We have taken a container such a way that there are two electrodes that are connected to the positive terminal. So this is the anode. Okay, and this is connected to the negative terminal. So this is the cathode. Okay, we pass NaCl solution, which is also called brine, into the particular container. Okay, and this particular container is divided into two halves by a semi-permeable membrane. Semi-permeable membrane. We know semi-permeable membrane allows the passage of water molecules, and there can be an exchange of ions that will be present in the particular container. Okay, now what is happening in this electrolysis? We know electrolysis is the breakdown of particular compound into its constituents by the passage of electricity. We have passed inside NaCl, so we have to have Na plus into the solution. We have Cl minus, and water we have H plus and OH minus. So when NaCl is dissolved in particular, say your water, we have these ions. So when electricity is passed into the solution, what will happen? The positive charge particles will be attracted towards the anode. So Na plus and H plus will be attracted towards the cathode, negative terminal, whereas in the positive terminal of the battery, the Cl minus along with the OH minus, they will come in contact. Now H plus ions, they come here and take an electron and they release H2 gas towards the cathode. Okay, moreover we can see that the chlorine comes towards the anode. Chlorine gives away the electron and one chlorine atom joins with another chlorine atom to give out the Cl2 chlorine gas, and we will obtain a little NaOH in the particular solution because of the presence of Na plus and OH minus. This Na plus and OH minus, they cannot get out of the particular in the gaseous form, so we take it out in the form of liquid NaOH. here comes the formation of NaOH. So we know why we are learning this electrolysis of water, or electrolysis of brine solution. A brine solution is a solution of sodium chloride into water, okay, which is found in abundance in the seawater and also in the rocks. This brine is very much useful for obtaining NaOH. What is NaOH? It is a strong base that is used for making different kind of soap, paper, detergents, or you can say it is also used for purifying bauxite to extract all aluminium. Okay. Now see here, this NaCl solution, when it is electrolyzed by the passage of electricity with the help of an external battery, okay, we can obtain Cl2 gas, H2 gas, and also NaOH. This Cl2 and H2, they can mix together to form HCl. Moreover, Cl2 gas is very useful for sterilizing water. Okay, it is also used as a disinfectant. Okay, hydrogen is a lightweight gas. It is used in liquid form in the rockets. Okay, it is used for making HCl. Okay, there are different. This is also used for hydrogenation. Okay, hydrogenation. So over here we see that NaOH is obtained by the electric dissociation of brine solution. Okay, let us recapitulate what we take in a container. Okay, we pass NaCl solution, which is also called brine, such that it is separated into the compartment of the container as the anode section and the cathode section, which is divided by a semi-permeable membrane. Okay, this semi-permeable membrane allows the passage of the ionic particles along with the water. So these ionic particles, when electric discharge is created, what happens? The positive ions is attracted towards the negative terminal, where H plus takes an electron and forms hydrogen gas, whereas the negative charge chlorine Cl minus attracts towards the anode and forms the Cl2 gas. Moreover, the remaining ions Na plus and OH minus, which is forming in this particular solution, is extracted as NaOH from the solution. Now, as in this process, we obtain chlorine, CHLOR, chlor, and we also obtain a alkali. This is a alkali. So this process is called chlor-alkali process. Okay. So in this chlor-alkali process, we obtain chlorine, hydrogen, and an alkali NaOH by the electric dissociation of brine solution. Clear? Let us see the chemical equation or reaction that is involved in this particular electrolysis of brine solution. We have taken NaCl, we have dissolved it in H2O. As a result, what happens? We obtain NaOH, we also obtain Cl2, and we also obtain hydrogen gas. Okay, we can actually balance it. Okay, Cl2, 2Na, now we have to give a 2 over here. Okay, I hope it is balanced now. So in this particular electrolysis, where we have to write here, electrolysis. Okay, by the electric discharge, NaCl is broken down into NaOH, Cl2 and H2. We know that NaOH is very important for us to make soap, detergents and everything. You can go through the book as well, different uses of NaOH, Cl2 and H2. Okay, so far we have just learned that NaCl is found in abundance in the nature as present in dissolved seawater and also in the rocks. We can mine and as well as evaporate the seawater to obtain the particular salt. But we know that NaCl is obtained from the acid HCl and NaOH. So the abundant salt that is present in our nature can be electrolyzed so as to obtain some useful chemical substances that are very necessary in our daily life. Okay. Next we are going to see that NaCl is also useful for the manufacturing of baking soda, okay, washing soda. We are going to see them over here. NaCl, when reacted with water, carbon dioxide and ammonia, leads to the formation of baking soda. Okay, what is baking soda? Baking soda has a formula NaHCO3. We know baking soda is one of the most important base that you can dissolve in water when you are feeling acidity and reduce the acidity of your stomach. Moreover, baking soda is also used in different ingredient different food. Okay, and moreover, baking soda is also used in your fire extinguishers. We are going to see how they are prepared and how they helps in a fire extinguisher. Okay, now when NaCl is reacted with H2O, CO2 and ammonia, okay, they leads to the formation of NH4Cl along with NaHCO3. Okay, this particular salt is your baking soda. This particular salt is your baking soda. This is used as a ingredient of an antacid. Antacid also contain baking soda. Okay, these are used in fire extinguisher. Okay, moreover they are also used just as a particular ingredient of different food. Okay, so NaHCO3, which is baking soda, can be prepared from the common salt that we eat. But in order to do so, we have to react the common salt with water, carbon dioxide and ammonia. Okay, that results to the formation of baking soda. Now what happens in a fire extinguisher? Let us talk about a fire extinguisher. Let us see if we have a fire extinguisher. Okay, the fire extinguisher must contain an acid which is H2SO4, which is H2SO4, and there must be a plug that has to be pulled. Okay, what happens when we pull the plug? We actually pull the thread and allow a particular small container of NaHCO3 to break and add with the H2SO4. Okay, now when NaHCO3 gets reacted with H2SO4, say NaHCO3 reacts with H2SO4, we obtain Na2SO4, a salt with the release of CO2 and H2O. With the formation of CO2 and H2O. See here very clearly what we are seeing, that the preparation of baking soda, which is prepared by NaCl with the reaction of water, carbon dioxide and ammonia, helps in fire extinguisher. Okay, how does it help? What happens? In a fire extinguisher that we see in different buildings that we have, what we need to do, we actually need to pull a particular plug. Okay, we need to pull a plug and we need to catch the pipe so as to spray the particular carbon dioxide over the fire. What happens there? First let us see here what happens. We pull the plug and this particular thread, okay, this gets torn and this particular container which contains NaHCO3 comes in contact with H2SO4. It falls down and there is an evolution of a gas. That is released by a pipe. Okay, why it is done? When fire catches, if we spray CO2 over that fire that doesn't come in contact with the oxygen present in the surrounding, and CO2 causes an envelope over that fire. As a result, because of the lack of oxygen, the fire extinguishes. Okay, let us see again what we have studied. NaCl is very useful for the preparation of baking soda. Baking soda, we know NaHCO3 when reacts with an acid H2SO4 releases carbon dioxide. Hence, it is used as a material present inside a fire extinguisher. What happens? The thread which is pulled actually releases the NaHCO3 to react with H2SO4, leading to the formation of carbon dioxide gas. The carbon dioxide gas, when there is a fire, okay, when the carbon dioxide gas envelops, when the carbon dioxide gas makes an envelope over the fire, because of the lack of oxygen, this fire doesn't come in presence or in presence of the oxygen which is present outside the envelope, and hence they extinguishes. Okay, we have seen a very simple experiment by taking a candle and a glass, okay, and a drinking glass. We can see that if we light the candle and place the glass upside down over the candle just extinguishes. It is because what happens, there is lack of oxygen present in the glass. Okay, this was how we have prepared baking soda, which is useful in this particular manner. Okay, the sodium hydrogen carbonate or the baking soda that is obtained by the NaCl can be used in the preparation of washing soda as well. Washing soda is a particular substance that is very useful for reducing the hardness of water. Okay, let us see how particular NaHCO3 leads to the formation of washing soda. Okay, now NaHCO3 when heated, the results in the formation of Na2CO3 plus H2O. The results in the formation of Na2CO3, H2O and CO2. Okay, let us balance it. If we take 2, then you can see it is totally balanced. 2 and we get 6, 3 and 2, 6. Okay, it is balanced now. Now, when NaHCO3 is heated, we obtain Na2CO3, sodium bicarbonate. Okay, sodium carbonate and water and carbon dioxide. Now, sodium carbonate Na2CO3 when reacts with 10 molecules of water, a single molecule when reacts with 10 molecules, it leads to the formation of Na2CO3.10H2O. Here comes the formation of your washing soda. So what happens, previously we have prepared sodium bicarbonate, which is the baking soda. It is prepared when NaCl reacts with water, carbon dioxide and ammonia, resulting in the formation of NaHCO3. Okay, now NaHCO3 is used in fire extinguisher. We have seen that. Now NaHCO3 when heated, they release sodium carbonate, which when reacts with 10 molecules of water leads to the formation of washing soda. This is only pure washing soda. This washing soda reduces the hardness of water. Okay, we need to reduce the hardness of water so as to use the cleansing property of soap. So this washing soda is prepared. If you remember this preparation of baking soda and so wise, you can memorize the preparation of washing soda. Okay, now let us see the preparation of bleaching powder. We know that when we have done the electrolysis of NaCl, we obtained chlorine gas. Now that chlorine gas, when it reacts with CaOH2, we know this is lime water. That is when your CaO is dissolved in water, we obtain CaOH2 with the liberation of heat. We have studied this. Okay, when lime is mixed in water, we form CaOH2. When this particular reacts with Cl2, leads to the formation of CaOCl2 with the release of water. This CaOCl2 is actually your bleaching powder. Okay, bleaching powder is used as a disinfectant in different hospitals. Okay, moreover it has many more utilities in the textile industry, also in the leather industry. Okay, so this was all the salts that we have seen today. We have seen that NaCl, which is the common salt. From NaCl we have obtained baking soda, we have obtained washing soda, and also this particular bleaching powder. Please go through the video. This particular part in this chapter is a little memorizing part. You have to keep all these reactions in mind when they will be asked. Later in the next video we are going to discuss about water of crystallization and also the different applications of water of crystallization. Thank you. Hope